Okay, arrange the following compounds in increasing pKa value. So in exam, this is a confirmed question, acidity, basicity of organic compound. Every year will come up, right? In the way. So the way I look at it is this. I structured my thoughts first. Increasing pKa values means therefore low pKa and then go to high pK. So you must do it in a very, very systematic approach. Else, a lot of people will go the other way around in their answer. pKa, we don't know. In our mind, it doesn't process. But we know very well Ka. And pKa and Ka are opposite because we learned this in the previous topic called acid-base equilibrium. All right? And Ka is directly proportional to the strength of a weak acid. Everyone okay? Make sense? So we always think in terms of Ka, not pKa. Let's highlight this and put it into 1, 2, and 3 so that I don't have to draw molecule. Molecule 1, 2, 3, right? So first of all, in the exam, how would I approach the question? In a very structured manner, ladies and gentlemen, I directly pick this up. I directly pick this up. This is different from this one. Because the green is an alcohol, the orange is a phenol. Make sense? And acidity-wise, I know alcohol is lower, less acidic. So immediately, I have my answer here. The lowest Ka is number 3, the least acidic. Next is to compare 1 and 2. All right, but now we need to write a statement out first, right? So let's write it out. So what I'll write is orange color. Okay, let's see. So I will say that in the phenoxide ion, what happened is the lone pair of electrons can delocalize the lone pair electron on where? On the oxygen atom. Can delocalize, localize into the benzene ring. Spamming up, we're going to write. In the phenoxide ion. Okay, and then resonance stabilization occur. All right, they're more stable. And then less tendency. First one, I'll write a bit more, later I'll summarize further, right? To accept back the H+, right? We always assume they have given out the H+. Remember when we talk about acidity? Which means they promotes ionization process. Which also means, therefore, they are more acidic. I.e., 1 and 2 are more acidic than 3. Okay? So 3 is right behind in my arrangement, having the higher pKa. So once I'm done with the orange versus the green, all right, green is out. I now have the 2 orange to take care. So what should I do? All right, take a look. The only difference is this one has the additional bromine substituent. And therefore, that's my answer in a short while. This Br is a what? It's an electron withdrawing group. Okay? So if you still remember, we don't look at the molecule itself. We look at the anion to talk about its lone pair. So if you look at it, if this has this amount of lone pair, the one over here, number 2, should have smaller because electron density has been drawn towards bromine. Okay, so I will therefore then write a note like this. I'll say bromine is an electron withdrawing group. So what? So it destabilizes, or rather it stabilizes. Give me a moment. Let me see which one I want to use. Electron withdrawing group. So it stabilizes. All right. It stabilizes the alkoxide ion. further. Right? So even lower tendency to accept H plus promotes ionization process further, and therefore this is the answer. 2 is more acidic than 1, and therefore that is my answer. 2, 1 in terms of arrangement. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.